In the previous video, we had discussed about the gaseous state and we studied about the properties of gases as well as we had the introduction to gas laws. So as I told you, in gas laws, always remember you'll have two of the values which are going to be variables and two of them are going to be constant. So the first gas law that we're going to be learning about is Boyle's law. So Boyle's law was given by Robert Boyle in the year 1662. So according to this law, I'm not going to talk about the law itself right now, but first of all, the two variables, you have two variables and two constants, right? So the two constants are going to be temperature and the amount of gas. And this basically means the number of moles of the gas, whereas the variable quantities are going to be pressure as well as volume. So basically in Boyle's law, we will be learning how pressure and volume are related, and this is done at a constant temperature and the amount of gas is also going to remain constant. For that, Robert Boyle actually used a J-shaped tube, something like this. Assume this is a J, but so here you have some amount of gas which is trapped. Okay, so there is some amount of gas which has been trapped over here. So we know that the amount of gas is not going to change because this is all mercury. So these two lines show mercury. Okay, so the amount of gas is not going to change. Also, the temperature is going to stay constant because this particular experiment was done in a constant temperature. So what happened was he increased the pressure on the gas by adding some amount of mercury to it. So first case you have it in black ink. Okay, second case when he added some amount of mercury, he noticed that there was, okay, this is not visible, right, there was an increase. When there was an increase in pressure, there seemed to be a decrease in volume. Okay, and again when he added a little more, he also again noticed that there was an increase in pressure, there was a decrease in volume. So that is the basic idea behind Boyle's law. He said that the pressure and volume are inversely proportional to each other, and this is at constant temperature and a constant amount of gas. I will repeat the experiment again. So what he did was he trapped some amount of gas over here. So this meant that the amount of gas is going to stay the same. And so this is basically mercury from here to here. When he added mercury, he thereby increased the pressure on the gas. And when the pressure was increased, the volume started to decrease. And so this meant that pressure and volume are inversely proportional to each other. And that is Boyle's law. So Boyle's law states that at constant temperature, the pressure of a fixed amount of gas varies inversely with its volume. So at a constant temperature and a fixed amount of gas, pressure varies inversely with volume. This is Boyle's law. So this is the constant temperature and amount of gas. Okay, and remember, you cannot state the Boyle's law simply as pressure. Pressure is inversely proportional to volume because this has been done under specific conditions. So conditions of constant temperature and the amount of gas, only then you have pressure is inversely proportional to volume. So when we remove the proportionality, we add in another constant K1, and this K1 is actually dependent on the value of K1 will depend on obviously the amount of gas as well as the temperature. And so from here we can get that P into V will be equal to K1. So at a constant temperature and pressure, I'm sorry, at a constant temperature, product of P and V of a fixed amount of gas would be a constant. So here again, this is another way this is basically a way we are putting this particular equation into words. At a constant temperature, okay, pressure, the product of pressure and volume of a fixed amount of gas is going to be equal to a constant, because K1 is the proportionality constant, so obviously it's going to have a constant value. So at a temperature, constant temperature and a fixed amount of gas, the product of pressure and volume will be a constant. So let's take another example. First, we have a V1 of a particular amount of gas. So in here, we will always talk in terms of a constant temperature as well as the same amount of gas. So V1 is the volume of a gas, of fixed amount of gas, at pressure P1. Oh, it'll be small. Okay, and next you obviously have V2 will be the volume of the same amount when pressure has been changed from P1 to P2. Pressure is P2. Okay, so when pressure is P2, then obviously this is both going to be at a same or constant temperature. So here, when you have V1, volume of a fixed amount of gas at P1 pressure, and when pressure changes from P1 to P2, the volume becomes V2, and this is going to be a fixed amount of gas and same temperature or a constant temperature. So then we can get a relation. Okay, we know that P into V is a constant, K1. So since we have the same same conditions of pressure and temperature same conditions of temperature as well as the amount of gas, in both the cases we can get this particular equation. P1 into V1 equals to P2 into V2. Okay, from here we have gotten this relation from here, and this is a constant at constant temperature. So from here we can also say that P1 by P2 equals to V2 by V1. So basically, when the volume of the gas is going to get doubled, the pressure is going to get reduced to half. And when it's tripled, the pressure is 1/3. So this is Boyle's law. Boyle's law, the first thing that we need to understand or know is that the constants are temperature and the amount of gas. They both are fixed. The variables are pressure and volume. So Boyle's law is a relation between the pressure and the volume of a fixed amount of gas at a particular temperature. So what he did was he took a J-shaped tube and he had a fixed amount of gas over here, and he increased the pressure by adding some mercury. And when he added the mercury, he noticed that when the pressure was increasing, volume was decreasing. And the more mercury he added, more pressure was exerted and volume further decreased. And that is where he got the idea of P directly being, inversely being proportional to the volume at constant temperature and the amount of gas. So from there, we got a constant K1. Remember, for all these equations, we'll be using constants. So each law we have denoted the constant of that particular law with numerical subscript for each of these constants. So for Boyle's law, it's K1, that's a constant. So we got the equation PV equals to K1. From this, we got to know that for a fixed amount of gas, the product of pressure and volume at a particular temperature, at a fixed temperature, is constant. So we also took another case where volume of a gas is V1 when the pressure is P1, and when the pressure is changing from P1 to P2, then the volume of that same quantity of the gas has changed from V1 to V2. From there, we got the relation P1 V1 equals to P2 V2, and that is a constant. So we just rearrange this and we got P1 by P2 equal to V2 by V1. With that, we are done with the introduction of Boyle's law. In the next video, we'd be discussing about the graphical representation as well as the experimental data. Do check it out.